So first of all, we are going to see about the robotic operating system, and then about the Lidar, and then we are going to see ROS system components and then tools, and we are going to interface Lidar with the Raspberry Pi for some kind of basic applications like mapping with the help of ROS, and finally, of course, we are going to have the discussion, tech news, and then Q&A. Okay, so that's it. So prerequisite for this course. So first of all, here additionally we are using RPLidar A1 and USB B type cable to interface Lidar with your Raspberry Pi. Okay, so first of all about the Lidar. So Lidar is nothing but light detection and ranging. So it is kind of a system or a device which is going to use the light to create a certain kind of pulsed laser to detect the range or to detect the sensors. So I hope we have already discussed about the ultrasonics, right? So ultrasonic is kind of like measuring the distance between one object to the another, or from the sensor to the another object with the help of sound. Okay, so like we have seen, like that is kind of echo and then trigger will be there. So with the help of the sound, we have estimated the distance, right? So same as like while talking about the Lidar, instead of sound, you're going to use the light. Okay, because since it is called like light detection and ranging. Okay? So it's going to use the light based pulsed laser light so that it can able to estimate or it can able to identify the distance between the sensor with the other object which is around our environment. Okay, so for this, in this project we are going to use RPLidar A1, which is done by Slamtech. Okay, so its specification is it is available with 12 meter range and 360 degree omnidirectional rotation, because here so if you want to take a Lidar or any kind of distance measuring or doing a mapping, so if you are taking a certain kind of, let us take ultrasonic, so it is kind of like projecting in a certain angle, right? So if you are projecting in a certain in a unidirection, like it is in like kind of one direction, so on the time you can't able to identify the complete map of complete throughout like 360 degree environment. Okay, so that's why this Lidar is made up of like 360 degree rotation purpose, so that you can able to map your environment in the X and then Y axis. This is kind of 2D Lidar, as well as there is a 3D Lidar is also there, so which is going to map complete dimension of a certain person or something like that. Okay, so this Lidar going to be the 2D Lidar, and the samples per time, that is 8,000 per samples, and the frequency 5.5 Hz. Okay, so and the technology, that is Optimac technology. Okay, so this is the Lidar which we are going to use in this session. I hope this session is going to be interesting. Okay, so please be attentive on the session, because in this session we are going to learn ROS and then Lidar based kind of application, okay, in real time. So it will be very great. Okay, so that's the main thing. So we are using a 2D Lidar, as well as we are going to use RPLidar model number A1. So that is going to be like 360 degree Lidar, as well as the detection range is going to be like 12 meters range. And if you want to go for like high range specification, it is also available. That is RPLidar A2 is also there. So there are a lot of versions of Lidar is there, like 2D Lidar, 3D Lidar. There are a lot of Lidar you can use. So here we are going to use RPLidar A1. Okay. So first of all, while talking about a ROS, so you may ask, what is the purpose of using ROS here? Because so here, if you want to do some kind of mapping, so you can also use robotic operating system to communicate with here this system or this Raspberry Pi to the MATLAB or some kind of application. Okay, so this is the better way to learning robotic operating system, because we are going to see a real-time application here. Okay, so here while talking about the robotic operating system, so it is nothing but robotic operating and system, right? So it is not like our normal robotic operating system like our Windows 10 or Ubuntu or Kali Linux, not like that. It is kind of a library, or it is kind of framework which is already holding certain kind of tools which is looking like a normal operating system. Okay, so this robotic operating system can be installed in your Ubuntu PC or in your Windows, so something like that. Okay, so this kind of library or a framework which can be externally installed in your laptop. Okay, like it can be installed in your laptop, because let us take a robotic operating system, so which is kind of, we are going to use a robotic operating system Kinetic. So that is one kind of version of ROS. So I'm going to install that ROS in the Ubuntu PC. I can do that. Same as like I can also install that kind of ROS in the Raspbian OS, which we are already doing. Okay, so that kind of thing can be done with the help of like robotic operating system. Okay, so this also will be helpful for having a intercommunication between a certain device with the certain device, or a robot versus the robot. So that kind of communication also can be done with the help of the ROS. Okay, so here in this picture we have two robots, right? So on the two robots, the communication can be takes place via the ROS communication. Okay, so that both devices already working on ROS. So with the help of ROS communication, that both device can able to do the communication. Okay, that is about robotic operating system. So while talking about the components of robotic operating system, the first component is topic. Okay, so topic means so let us take same scenario, like I'm having my YouTube channel. Okay, so let us take a Pantech. So Pantech Solutions there is a YouTube channel. Okay, so I'm going to post some of the information to you. Okay, so for example, I have already did we have already did like certain kind of projects. We are going to post that project. Okay, so we are going to post that project in the YouTube. So on the time, so I'm going to post that video in the name of Pantech Solutions, or we'll put up some title we'll put up some titles such as like autonomous car, how to design an autonomous car. So that is a title. Okay, so I'm going to assign a certain topic to the certain project, and I'm going to publish that video in the YouTube. Okay, and the participants, whoever subscribe to the Pantech Solutions channel, they can able to receive that notification, right? So first of all, we need to have the topic. So for example, I have my message. So here, what is the message? Message is nothing but a YouTube video. Okay, that autonomous car design video. So that video going to be the message. For that message, for the complete video, I'm going to assign a certain title or topic. So that is known as topic. Okay, so it is not going to be like YouTube, or not only the YouTube video or something like that. Some of the device. So like let us take a robot. Okay, so this robot going to send something in the name of certain topic. So that component is known as topic. And then node is there. So node is nothing but kind of communication node. So for example, so let us take a Pantech Solutions YouTube channel. So I am also one of the node because I was subscribed to it, and Pantech Solutions is also one node. Okay, Pantech Solutions YouTube channel is also another node, and the participants we have. So those participants are also the nodes. Okay, so they have already connected to a certain network or certain channel. Okay, so those are all nodes. So for example, here there is a two robots, and also there is a third robot. So it's going to publish some data. So okay, so that going to publish some data. So if that this robot, that robot A going to transmit some data. So robot B and then robot C is also connected with here means. So number of nodes going to be 3. Okay, so that's about the node. And then third component, that is a publisher. So publisher, of course, like let us take a same YouTube channel of Pantech Solutions. So Pantech Solutions going to publish one YouTube video. So that part is known as a publisher. Okay, who is going to send, or who is going to project the data. Okay, so that term is known as a publisher. So that component is a publisher component. And then while talking about the subscriber component, of course we know. So whoever subscribe to the certain topic, so they are going to receive that video. So those are all kind of known as subscriber. Okay, whereas while thinking about the service, so in a service you can specify, like you can specially say in a single word, like it is kind of synchronous remote procedure. Okay, single sentence, like synchronous remote procedure. Whereas action, that is asynchronous. Okay, so service means synchronous, action means asynchronous. Why we are calling that is like while talking about the service, so it is having a synchronization between the transmitter as well as the receiver. Okay, so for example, I need to so here there is a one robot. Okay, so one robot is here. I want to make that robot to turn left. Okay, so on the time what the service will do, so it will post the data to turn right. But on that robot, first of all, it will complete its own work, that is to going forward. Okay, so it will have that synchronization. Like there is something already running there, so we need to have the sync between it, and we need to put the current task which is sent by our user to be like in a pending state. So once the forward is completed, then it will turn left or right. So what based on the command. Okay, so that's about the service. But whereas that action, so action is kind of asynchronous. Asynchronous means like it doesn't like it don't want to wait for a certain result to do a certain task. Okay, it will do parallelly. Okay, parallelly, or you can do like kind of same thing kind of thing, like so it is like forward, so it is kind of interrupt. So interrupt means it will do that and it will follow, or it will continue the previous process. So that's the difference between action and then services. So services means that is synchronous, action means asynchronous. Okay, so that's all about the component of robotic operating system. Okay, so and then on detail, so we'll study on detail. So ROS topic, so what is mean by the ROS topic? We have already told. So whatever the message which we are going to transmit from one place to another, so we are going to keep one name for the data, title for the data. So that is known as ROS topic. For example, so here Lidar is already scanning the data around the environment. Like what is the here it is already rotating in 360-degree angle, right? So like 360-degree rotation. So for each and every degree, so there is some distance. So for example, here I am here. So on this degree, laptop is in front of me. So it may be in the distance of like 5 centimeter. Okay, so 5 centimeter. So on the 0th degree and then 360th degree, so there is a 5 centimeter. And let us take this side. So this side, there is no laptop. It is a free space. So on that free space, the centimeter or the distance between me and then that wall is 220 centimeter. So 220 or 200 centimeter. So 200 centimeter in the angle of 45 degree and in the 90 degree. So in the 90 degree also there is a wall, but it is little bit closer. So on the time the distance is going to be like 200 instead of 150. Okay, so 150 centimeter. On the back side the wall is very closer to me, so like it is up to like 50 centimeter. Okay, so for each and every angle, so it's going to have a certain distance, right? So Lidar is going to get the data for 0th degree, what is the angle? 1 degree, what is the angle? 2 degree, what is the angle? 3 degree, what is the angle? So for up to like 360 degrees there. Okay, so for 360 degrees, also we'll get the 360 values of distance, and then it's going to transmit something in the name of /scan. Okay, so here in the presentation that /scan represent the ROS topic. Okay, so whoever subscribe to the topic called /scan, so they are going to receive the data of this Lidar. Okay, so that is the main thing about the /scan. And the commands which we can use it like to identify the ROS topics and those things, you can use the command called ROS topic space list, which means it's going to list out the ROS topics. So what are the topics are there? Is either it is a scan or either it is like kind of, for example, so there is one robot or robotic system which is already installed in Raspberry Pi. So what are the topics they are using? For example, I can able to transmit the distance and an angle Lidar data in the name of /scan. And then accelerometer value in the name of /mems or /accelerometer, and kind of like temperature. So temperature value in the name of /temp. So that kind of thing can be it will be already there. So whatever the ROS topic this certain ROS is using, so it's going to list out with the help of passing the commands called ROS topic space list. Okay, so and then if you want to know about the topics information, so for example here already the /scan is going to transmit the data of that angle and then distance, right? So if you want to identify this topics information, so you can pass the command called ROS topic space info space topic name, which means /scan. So for example, ROS topic info /scan, so which means it's going to give you the results what kind of data is. It is a sensors messages and it is a laser scan. So I have described in this presentation. Okay, so for example, so ROS topic info space /scan, which will give you the data or the information like sensors space messages plus laser scan. So it is a kind of data, it is about laser scan. And if you want to receive the data, okay, so up to now first of all we have seen the what are the list of ROS topic list, and then second we have seen information of the certain topic, like what is kind of format of the data. And then if you want to receive the data directly, you can use the command called ROS topic space echo. So which echo space and then /topic name. So if you specify like this, then you will get the data. So here what is the data? That is ranges, angles, minimum angles, maximum angles. So those kind of data will be obtained from the Lidar here. Okay, so ROS topic echo space /scan, so it's going to give the data of this Lidar. So what is the angle? So 0th degree 5 centimeter, like 45 degree 200 centimeter, 90 degree 150 centimeter. So like that it's going to give you the data. So that's about the ROS topic echo. Okay, so I hope you understand this ROS topic, and then we'll go for the ROS node. So as I have already told you, the ROS node is in the sense the kind of interconnection, like so I am the one of the node, and the devices which is connected with the certain ROS, so those are all going to be the nodes. Okay, so it's going to represent how many subscribers and how many publishers. Okay, so if you want to know the ROS node list, so how many devices are connected. So for example, so here there is a Raspberry Pi which is already installed with the robotic operating system. It is already getting the Lidar data. So if this ROS is connected with the MATLAB software with the help of robotic operating system software packages, then in the ROS node list it will show the IP address of the system and the MATLAB software is using, or MATLAB software is one of the subscriber or one of the node. So that like kind of thing. Okay, so that can be represented with the help of ROS node list. Okay, so and then RQT graph. So RQT graph is nothing but it's going to give you the graph kind of representation, like which node and where it is connected. So how it is connected. Okay, that kind of graphical representation will be given, or it will be like shown to represent how many nodes are there, where it is connected. So those things can be represented with the help of ROS node. Okay, so I hope you got this. So that's about ROS topic and then ROS node, and then we are moving on to the ROS service. So as I already told you, so ROS service is here. Okay, so ROS service. So if I want to send something, okay, so I'm going to send something, like for example I'm going to send a command like to turn left or to turn right. So let us take, so robot is already moving forward, so I'm giving the command turn right. Okay, so turn right with the help of ROS service, in the name of ROS service. So it will terminate by going forward and it will turn right again, and then it will follow up the previous process. Okay, so that's about the service. So for example, and another main thing, so for example if you are going to start the service, you can start the service by putting like ROS launch a service demo service. So what is the service you need to launch? You need to launch in the first terminal. And if you want to call a certain function, so you can call the function in the syntax called ROS service call. What is the service? So either it is going forward, or whether it is going to be turn left or to turn right. So those kind of command can be sent with the help of ROS service. Okay, so that's about the ROS service. And then action. So action in the sense, so action is also going to be similar between that like previous services, but it has the difference. So it won't terminate the certain process. Instead of that, it will wait for it. Okay, so it won't. There is no. There is a kind of synchronization. So synchronization in the sense, it will wait, or it will know the previous process which is already running there. So that command. So if let us suppose to have the same example, the car is moving forward already. So I'm going to give the command to the car to turn left. So on the time I'm going to give the command like to turn left means, so the command will be posted there. The command means the action is posted there, but it will wait for the previous command should be run before. So once the forward command is completed, then it will execute the second process, that is to turn right. Okay, so that is the working procedure of action. Same as like the service, we need to start the action in one terminal, and we need to call the certain action by using the another terminal. Okay, as like services. Okay, so and while talking about the robotic operating system versions, there are a lot of versions. So here we just talked about like May 23, 2020, but after that also we have already lot of versions of robotic operating system. So these are all like versions and then dates, year when it is published and those things. Okay, so I think you can able to see that. Okay, so and then tools of robotic operating system. So while talking about the tools of robotic operating system, the first tool is RViz. So here the tool which we are going to explore is RViz and then ROS launch. Okay, so RViz in the sense it's going to have the graphical or a kind of three-dimensional visualizer where you can able to visualize the map of the complete environment. So for example, we are going to ROS launch this RViz display, so that it's going to give you the graphical representation where I can able to show the Lidar here, so that it will map my 2D environment, so that it will show like complete map of my room. Okay, so that kind of visualization can be done with the help of RViz display. And a ROS bag. So ROS bag is kind of tool which will be helpful for recording the ROS message data. So it may be like previously sent, but that may be missed on the time. So to kind of having a playback or to record it, like to record the data and to have a playback. So that kind of format is known as that kind of tool is known as ROS bag. And then Catkin. So Catkin is nothing but it is going to be collection of CMake macros, because I hope we have already seen about in artificial intelligence masterclass about CMake, like to install or to make that library. Okay, so that kind of packages will be combined and it will be kept inside the Catkin tool. And then ROS bash. So ROS bash provides like it will be like providing the functionality of bash shells. So for example, bash shells in the sense to hold the information about the IP address, to hold the information about which IP address this connected and with what are the nodes there, how to communicate those kind of bash files. So what are the configuration files which will be present inside that ROS bash. And then ROS launch. So ROS launch is a kind of tool which will be helpful for to launch the ROS file. So for example, here the ROS is also one of the tool where that functionality is going to display the graph in the ROS display. But with the help of ROS launch, you can able to launch the ROS file. So ROS file, in the sense, it can be created with the C++ program or the program which is already written there. So you can also launch that ROS file. So like for example, if whenever you are running the program in a Python program, for example, so you'll go to the option called run and then run module, right? So in the ideal. So same as like the ROS file or the ROS programmed file, the ROS application file can be run or can be launched with the help of the tool called ROS launch. Okay, so I hope you have explored the robotic operating system a little bit, like to seeing RPLidar. So here in this video, RPLidar is already starts rotating. So RPLidar A1, which has a certain module, that is black color module, which is already present here. Okay, so that module, so with the help of that module, that RPLidar is connected with this Raspberry Pi by using this black color USB B type cable with the filters. Okay, so that's up to the connection. So other than that, it doesn't require any other connection. So and then you are also seeing the picture or video stream of ROS robotic operating system, which is already shown in this video. Okay, so this looks different. It is not looking like Raspbian. Okay, so first of all, before visualizing the graph or map of this lidar, so we need to do certain kind of configuration which is essential for ROS. So before going on to that topic, so first of all, I would like to say tell about some few things. So first of all, here RS display is going to be one node or the subscriber. Okay, so the publisher going to be the ROS master. Okay, so ROS master going to get the data from the lidar and it going to publish to the RS display. Okay, so ROS master going to be our Raspberry Pi normal robotic operating system. So and then inside that same robotic operating system, we are going to use one RS display. So that RS display going to be the slave or a subscriber kind of thing. Okay, where it's going to retrieve the data from the topic name /can and it's going to display it in the display. Okay, so now you have this display, right? So on the display, first of all, you just go to the bottom right corner. Okay, so bottom right, so there will be like tower symbol or X mark symbol. Okay, so on the time on where you just want to put disconnect. Okay, you just click disconnect and that icon will be look like a monitor kind of symbol, and then again you just click it and look for the Wi-Fi address. Okay, so Wi-Fi which is present in your home, and you just connect it. So after connecting it, you can able to see the tower symbol there, so which represent that this Raspberry Pi OS which is connected to the network. Okay, so after that, what you need to do is you need to identify the IP address. So for that, you just open this, you just click this icon and go for the connection information. Okay, so in the connection information, that it will that in the keyword of IPv4, so it's showing the IP address, that is 192.168.10. Okay, so so this is the IP address we need to configure for our master. So for configuring, what you need to do is you just press Ctrl Alt T. So okay, so that it will open the terminal, that is LX terminal. So, okay, so on that LX terminal, you just simply press up arrow. Okay, to locate the keyword called gedit.baskrc. Okay, so I think you can able to see this in this video. So that is named gedit.baskrc file. This is the bash file which we have already seen on the previous slides. So gedit.baskrc, you just press enter. After doing enter, so it will open one notepad or a baskrc file. So on that file, on the last area, that is mean export ROS master URI, export ROS hostname, export ROS IP. So okay, so these are the three options. So on that, here what we are going to do, we are not going to use any other external kind of interface. Here the ROS master is going to be like our operating system. So from that, we are going to retrieve the data from the sensors and we are going to publish it in the RS display. Okay, so this kind of operation going to be happened inside the Raspberry Pi itself. So here, first of all, we need to configure who is the master. Okay, so that means ROS master URI is equal to http://192.168.10:11311. So 11311, which resembles the port number. Other than that, this is the IP address which we have identified in the menu of that connection information which we have seen here. So you just go for that menu and then the connection information. So here 192.168.1.10. Okay, we need to configure it here also, like 192.168.1.10. And after that, ROS host name. So ROS host name is also 192.168.1.10. and ROS IP address, because this every operation or every application which we are going to perform here is going to be happen inside the Raspberry Pi, within the Raspberry Pi. So we need to configure the same IP address for three options, like 192.168.10, again 192.168.10. Okay, so three IP address are configured in this menu. Okay, so after changing your IP address, because it may be changed for your network, you just want to change it and you just press Ctrl S. Okay, so that's it. After changing the bash shrc file, you need to do the reboot. So for that, you just type sudo space reboot. Okay, you just press enter, because I've already done that configuration. So if you click that reboot, so again it will open the menu, or again it will restart the Raspberry Pi. Okay, to boot the same OS. Okay, but that bash shrc file, that bash file will be changed now for the IP address which we have configured. Okay, so after done this kind of configuration, you just plug in the Lidar as per given in the picture. Okay, so you just want to connect via USB port. Okay, you just connected, the RPLidar is connected in the USB port of the Raspberry Pi. And after that, again you just come for this menu and press up arrow and look for the option called ROS launch space RPLidar underscore ROS space view underscore RPLidar dot launch. Okay, so this is the syntax to launch this RVS display, which going to display you the graph or map of this environment. Okay, for that you just press enter. Okay, first of all it will check the summarizing and it's going to open the RVS display. Okay, so now I think you can able to see that red color dots which are representing the graphs. So for example, if I'm going to move this lidar, okay, so I'm going to hold this lidar. So you can able to change, or you can able to see the variation in the graph plots. So I'm going to open, or I'm going to hold like this. Okay, now if you are seeing here, so this complete map of this room is obtained here. Okay, so I'm just holding it. Not a proper way to hold like this, but for demo purpose, I'm just holding this lidar like this. Okay, now you are seeing the graph. Okay, so the graph is representing, or it is taking the complete map of this room. Okay. So to show the variation, I'm going to show my hand. So here I'm just showing my hand. Okay, so while showing the hand, the changes is occurred in here. So you just see this spaces. So this space is me, and this space is a door, and this is the object which is present nearby. Okay. See here, there is some kind of variation in the lidar. Okay, so rotating this one, the graph is also rotating. Okay. Likewise, this can be changed here. So here near to the laptop. Okay, so lidar is still rotating. Okay, so likewise, we are just obtaining the map of the complete environment. So by obtaining these kind of map with the help of the robotic operating system and then lidar. Okay, it's still taking the values, and still it is displaying in the RVS display. Okay, so I hope you got this. So I'm repeating the functionality. First of all, you just open the Raspberry Pi operating system, this operating system which we have already did. Okay, so before that I just plugged in this Lidar, RPLidar with the Raspberry Pi, and after booted the OS, so first of all it will ask for the username. So our username is Ubuntu, and then password is Pantech. And after going in, first of all you need to connect with the internet. So for connecting with the network, so first of all you just go for the bottom right option. So network, you just click a disconnect button. Again you just click the network button. Then after you just go for the again that option, same option. You just look for the connection information. So on the connection information, you're going to show the IP address. So IP address in the sense, what is the IP address means, like 192.168.1.10. Okay, so that IP address will be there. And after that you just press Ctrl Alt T. So after going there, so you just press up arrow to locate the command called gedit. Okay, so gedit. Okay, so we'll look for the option. Okay, gedit.basc users press enter, and after that it will open one notepad file. Okay, so on that notepad file, what you need to do, you just want to change the IP address of 3 IP address you need to change, or you need to put the same IP address for 3 menus, like one is ROS, master URI, and ROS host name, and then ROS IP. Okay, so on 3 places you need to change, or you need to put your IP address, and after that you just press Ctrl S to save it and close this one, and you just type sudo sudo space reboot. Okay, so that this Raspberry Pi will be rebooted. So after that you just look for, again you just press up arrow to look for the option called ROS launch, RPLidar ROS view, RPLidar.launch. Okay, so here I have connected this Raspberry Pi with my monitor and then keyboard and then mouse. Okay, so that's it. After pressing the enter, you can able to see these graphs and the error possibilities. While talking about the error possibilities, if you are getting error like ROS USB is not found, that kind of error means, so which means you are not plugged the lidar properly. Okay, so other than that it won't give any error. So if it is giving any kind of not able to communicate, those kind of error, so the possibilities of the error going to be like you haven't configured the Wi-Fi properly. Okay, so these are the possibilities of the error. Okay, so I hope you got this, like how to work on this RPLidar with the Raspberry Pi with the robotic operating system. So I hope you all